Hello students. So the motion chapter and lecture 3 we will continue. Today's topic, that is the types of vector. Right. Now first thing, the vector, that means it is the quantity, physical quantity that has magnitude as well as the direction. So as we have seen that this will be a vector AB if it has some magnitude, also some direction here, right? So this vector concept is very clear to us. Now there are 10 types of the vectors: zero vector, unit vector, position vector, co-initial vector, like or unlike vectors, coplanar vectors, collinear vector, equal vector, displacement vector, negative of a vector. So among these 10 types of the vectors, most of the types already we have discussed. So here the zero vector, from this we will start. Here you can see in this diagram, this is a vector and it has some magnitude, also the direction. And this is called zero vector. That means what? A zero vector is a vector when the magnitude of the vector is 0. That means the magnitude means what will be the length, or if we take this is 4 meter long or 2 meter long, this type of, so the magnitude of the vector will be 0 and the starting point of the vector coincides with the terminal point. Here you can see that the starting point is this one, and the ending point is also this one. So what we can say that it has no magnitude. It has no magnitude. This is a point, right? It has no magnitude. I cannot define that it is 2 meter length in length or 3 meter or anything else. So the magnitude of this, the dimension, you cannot tell any dimension of this point, right? So this is the zero vector. The starting point and the ending point here both are coinciding. So this is the zero vector, right? Is it clear, zero vector? So next we will move to another thing, that is the for a vector that coordinates of the point A are same as that of the point B. That means suppose coordinate of point A, suppose you have 4, 3 and coordinate of point B, that is also 4, 3. That means what? The same point, if this is the X and this one is your Y. So 4, suppose this is 1, 2, 3, 4. And this one is 1, 2, 3. So 4, 3, that means some point, this is some point here, right? So the A point that collide with the B point, right? So that means the vector, the coordinates of the point A are same as that of the point B, then the vector is said to be zero vector, and it is denoted by 0. So it is denoted by what? 0. So this follows that the magnitude of the zero vector is 0 and the direction that we cannot find out the direction. So the direction we cannot find out, and zero vector, the magnitude is 0. The magnitude is 0. Okay. So then unit vector. So here you can see in this diagram, this is x-axis, y-axis and z-axis. And here a vector which has the magnitude of unit length, right, is called the unit vector. Here you can see that I vector, j vector, k vector. Generally the I vector we are considering along this x-axis. J vector we are considering along the y-axis, and K vector we are considering along the z-axis, right? So, the unit vector means its magnitude should be unit length, right? If it is 1 meter, 1, then if it is 2 meter, it is not a unit vector, right? So, here, suppose x is a vector having a magnitude x, then the unit vector is denoted by this x in the direction of the vector and has the magnitude equal to 1. So, here you can see that our x vector that equals to the x vector divided by magnitude of this one, that should be equal to 1, right? So this is our unit vector. So what is unit vector? The magnitude of unit length. The vector which has the magnitude of unit length. That is the unit vector. Okay. And the value of this x vector divided by magnitude of x, that equals to 1. So any two unit vectors must not be considered as equal because they might have the same magnitude but the direction may be different, right? So here, suppose this is one vector, this one is another vector, right? So this was I cap and this was j cap as per the previous diagram. So what? This is also unit vector, this is also unit vector. That means what? If I cap, this is the unit vector, so this will be our equal to j cap. But it does not mean that our I vector that is and j vector both are in the same direction, because you know that the I vector in the previous case, the I vector along the x-axis and the j vector along the y-axis. So what was the diagram here? So suppose this is the x-axis and suppose this is the y-axis. So this is our I vector and this is our j vector. Both are unit vector, but you can see from the diagram, this I vector is a unit vector, but it is along the x-axis. But j vector is a unit vector, but it is along the y-axis. Similarly, if we take z-axis, so you can see that your k cap, that is also unit vector. This is also unit vector. That means what? I cap, j cap, k cap, all these things are, all the vectors are unit vector. But you can see that the direction are different. I cap along x-axis, j cap along y-axis, k cap along the z-axis, right? So, two unit vectors must not be considered equal. Two unit vectors must not be, you should remember this thing, must not be considered as equal because their direction in which the vectors are taken might be different. Now, the co-initial vector. Now, the name co-initial. That means what? Initial point of the vector, that is same. Co-initial, right? So, co-initial means initial point of the vector will be same. If I will take one vector here, AB and AC, here you can see that this A point, it is same for the AB vector as well as for AC vector, right? Both are different vectors, AB and AC. But what I have seen that the start initial point or the tail of AB vector and AC vector are same, right? So that means the coordinate of this point A, the coordinate of this point A, that is equal for AB vector and for AC vector. So these are called co-initial vectors. These are called what? Co-initial vectors. That means the vector, suppose I have three different vectors. I have three different vectors, right? So many vectors are there. And here, suppose this is the point O, A, B, C, D, E, F, G. So how many vectors are there? Here you have OA vector, OB vector, OC vector, OD vector, OE vector, OF vector, OG vector, lot of vectors. But they are originating from a same point. That is the point O. That is the point O. So those are that OA vector, OB vector, OC vector, all vectors are co-initial vectors. All vectors are co-initial vectors because the point O is the same. That means the initial point or the originating point is same for every vector. That means the coordinate of the O vector that is same for every vector. The coordinate for the point O that is equal for every vector here, right? So that is the co-initial vectors. Co-initial vectors. Now the position vector. If O is taken as reference of origin, here in this diagram we have taken O as the reference of origin. O has taken reference of origin and P is an arbitrary point in space, then the vector is called position vector OP, right? That means some initial point or O origin vector. This is the origin of this vector and this vector is denoted by OP, right? So this vector is denoted by OP. So this vector is originating from O and it is up to P. So P is an arbitrary point in space. Then this vector is called position vector. Position vector. So position vector simply denotes the position or location of the point in the three-dimensional Cartesian system with respect to the reference origin. So if I have X, Y, Z, suppose these three planes, and some vectors you have here, that is O, P. Here you can see that this is OP vector is the position vector. OP vector is the position vector. Okay, so this OP vector position, the O point, it has the position what? The O point coordinate is 0, 0 and 0. 0, 0 and 0, right? This is the coordinate of O point, right? Similarly, I can take another O point that has the coordinate 1, 1, 1. So this is the position vector. Next, like and unlike vectors. So the vectors having the same direction, right? Same direction are known as like vectors. Suppose I have a vector here, AB vector, another vector here, CD point. So CD vector, let I am giving the name CD vector. So both in the same direction, that means along the x-axis. So both in horizontally you have, both in the same direction. So at that time, these are like vectors. And the vectors that have opposite direction with respect to each other. Suppose this one and this one. So this is our AB vector. Suppose this is our CD vector. So that means what? They are in opposite direction. So at that time we are saying that these are unlike vectors, right? That means suppose I have x-axis, y-axis, z-axis. So here I have two vectors. One is the AB vector, another vector that is the CD vector. So they are where? They are along the positive x-axis. But if AB and CD both are in opposite direction, then these are called unlike vectors. That means the like or unlike, that depends on the direction of the vector. Both may be of same magnitude. Remember one thing, both may be of same magnitude or different magnitude. That is not so much important to define the like or unlike vectors. But here the same direction should be there, that is the like vectors, and for unlike vectors there are two vectors or three vectors, whatever you are taking. All these vectors should not have in the same direction, right? So these are the like unlike vectors. Next is the coplanar vectors. Now here, if I draw the plane, roughly I am drawing this. So this is a plane. This is called another plane. Like that, if I draw X here, Y here, so this one is my XY plane, right? This is my XY plane. Suppose I have Z here, so this will be my YZ plane. This will be my YZ plane. And this will be my what? XZ plane. This is the XZ plane, right? So this is one plane, this is another plane, and this is the third plane, right? So coplanar vectors means three or more vectors lying in the same plane or parallel to the same plane are known as coplanar vector. So coplanar vector means all lying in the same plane. If XY plane, suppose I have a vector AB here, then I have a vector CD here, I have a vector PQ here. So that means in a same plane I have all the vectors. So let me draw this thing very clearly. X, Y, and this is the plane. So here I have AB vector, I have CD vector, it may be I have another PQ vector, right? PQ vector. So all these will be in a same plane. That means what? They are coplanar vectors. They are coplanar vectors. So more vectors lying, three or more vectors lying in the same plane or parallel to the same plane are known as coplanar. Now one thing very important, that if all these vectors are lying in a same plane, this is coplanar, or the vectors which are parallel to XY plane or your YZ plane or XZ plane, these are also called coplanar vectors, right? So collinear vectors. Now collinear vectors that lie along the same line, or parallel lines are known to be collinear vectors. Collinear vectors. Along the same line or parallel lines, they are also known as parallel vectors. That means, suppose this is AB vector, this is CD vector, both are parallel, or AB vector, after that you have CD vector after this point. Okay, so this will be in the same line, lying in the same line. So vectors that lie along the same line or parallel lines are known as collinear vectors. Collinear vectors. So they are also known as parallel vectors. They are also known as parallel vectors, right? Two vectors are collinear if they are parallel to the same line, irrespective of their magnitude and direction, right? That means two vectors, Suppose I am drawing here. One vector is this, another vector is this. Some long. So this vector, if I am giving the name AB and CD, these two vectors are parallel, but the magnitude not same. Also, their direction not same, right? The magnitudes are not same, also the directions are not same. That means what? They are parallel. That's why I am calling, yes, these are the parallel vectors or collinear vectors. So two vectors are collinear if they are parallel to the same line, irrespective of the magnitudes and direction. Irrespective of the magnitude and direction. Thus, we can consider any two vectors as collinear vector if and only if these two vectors are either along the same line or these vectors are parallel to each other in the same direction or opposite direction. In the same direction or opposite direction. That already I have described here, that these two are in same direction and these two they are in opposite direction, but both are collinear vectors, right? This set and this vector set both are collinear vectors. Okay, so this is the collinear vectors. Collinear vectors. Here you can see this one and this one. Just compare these two pictures. These two are parallel vectors. Here in this picture, these has the same magnitude, but it is not always mandatory. So these collinear vectors have the same direction, right? Suppose I am giving the name AB, CD. Let it be PQ, RS, right? So PQ and RS vectors, these are also collinear vectors or the parallel vectors, but main difference is that their direction. You can see that the tail of the PQ vector, here, whereas the head of the RS vector here, right? That means they are in the opposite direction, but they are parallel to each other. So that's why these are collinear vectors. But these two are not collinear vectors because there is some intersection point here. There is some intersection point here. They are not parallel. If they will be parallel, then we know that they should not, if we extend also, they should not intersect each other. So here the collinear vectors which are parallel, but it may be their directions are different or same. Okay. So for any two vectors to be parallel to one another, the condition is that one of the vectors should be a scalar multiple of another vector. Scalar multiple of another vector. The figure shows the collinear vectors in opposite direction as well as in the same direction. Right? So this is the collinear vectors. Now the equal vectors. Two or more vectors are said to be equal if their magnitude and direction both are same. If it has 4, it should be 4 meters. Right? That means the length of the vector of AB, this is AB vector, this is PQ vector. So AB vector and PQ vector both are equal vectors as their magnitude and directions are same, right? So AB vector, that is the magnitude and also the direction. That means Here the direction towards this side. So both the direction and the magnitudes are same. That's why these two are called equal vectors. So remember one thing, equal vectors, that means their magnitude and direction both should be same. Both should be same. If magnitude is same, direction is not same, I cannot tell that these are equal vectors. But if they are equal vectors, their magnitude as well as their direction should be same. These two factors should be same. Remember this thing. Now the displacement vector. If a point is displaced from position A to B, then displacement AB represents a vector that is AB. So already I have described, suppose point A and B. So this is AB vector. So if a point is displaced from position A to B, then the displacement AB represents a vector AB. So this is the displacement vector, right? I have started my journey from here and I have moved up to point B. So this AB vector is the displacement vector. Negative of a vector. If two vectors are same in magnitude but exactly opposite in direction, right? Fine. Let this is the A vector and this is another vector B. Both are same magnitude. Okay, both are of same magnitude. So if two vectors are the same in magnitude but exactly opposite in direction, right? Opposite in direction, both of these. So these vectors are negative of each other. Negative of each other. So provided, you should remember one thing, their magnitude should be same. Their magnitude should be same. Until unless you cannot tell these are negative vectors. This is negative vector. So here two vectors A and B we have taken where these vectors are exactly the same in magnitude but their direction in opposite side. Okay. So their direction that is opposite. Their direction that is opposite. That's why it is the negative of a vector. That means your A vector that is minus of B vector. A vector that is minus of B vector. Or I can say B vector that is minus of A vector. Right? So one vector is negative of the another one. Now the question comes, so vector which has the magnitude of unit length, fine, unit length, this term is very important. This is called which one? Zero vector, position vector, unit vector, co-initial vector. Which one? This is unit vector. This is the right answer. This is unit vector, right? So vector which has a magnitude of unit length is called unit vector. Next question, a vector whose magnitude is equal, fine, magnitude is equal, also their direction are same. Okay, so these are called equal vectors. In the definition of equal vectors, we have studied that their magnitude as well as direction both should be same. Both should be same. So that's why the correct answer is the equal vectors. The vectors which have the same starting point. Fine. I have drawn, can you remember this thing? I have drawn one point from where some rays of light you can see, right? And this is the originating point O. This is A, B, C, D. So what was the type? That is the co-initial vector. So if the starting point or the initial point is same, then co-initial vector. Co-initial vector. The vectors having the same direction are known as which one? Position vector, like vectors, co-initial vectors, equal vectors. Same direction you have. Same direction you have, that means like vectors, right? same direction you have, you can call, yes, like vectors. Okay. A vector whose magnitude is 0 is called zero vector, because in the zero vector definition, whatever we have told, we have taken one point which is starting from here and ending also here, right? So terminating also here, and it has no magnitude. So magnitude is 0, and direction, that we cannot determine the direction. So the right answer is the zero vector. Thank you. This much for today.